Welcome, everyone. Thanks for joining us today for our latest webinar, A Holistic Approach to Industrial Security, How to Detect Cyber Attacks in Substation Networks. My name is Beth Capellas, and I'm the Marketing Manager here at Triangle Microworks. We are ready to get started, but I'd like to go over some housekeeping items while folks are continuing to join. The webinar is scheduled to be 1 hour long. We typically get a large amount of questions, so we are happy to stay on longer to answer as many questions as possible. With that said, I'd like to encourage questions throughout the webinar. Since the audience is on mute, please submit your questions using the webinar menu under the section titled Questions. You can start asking your questions as soon as you have them. Don't feel you have to wait until the end. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly. And again, we will have some at the end to go over questions and answers. So with that, I would like to introduce our speakers. First, we have Matt Green. Matt is a senior applications engineer here at Triangle Microworks. He has been with us for about 6 years and specializes in QA testing in all our simulation tools and gateway. Our second speaker today is Sharon Brizinal. Sharon is a vulnerability research team lead at Clarity. He is responsible for finding new ICS attack vectors and has over 7 years experience in network security, malware research, and vulnerability research. So with that, I would like to hand it over to Matt to go ahead and get started. Okay, Matt, I'm making you presenter now. You should have the screen.
All right, so we're going to start this off a little bit by talking about a little bit of our companies. So as Beth said, my name is Matthew Green. I am a senior applications engineer here at Triangle Microworks. A little background about Triangle Microworks is that we were established in 1994, and we've been working in the protocol communication fields ever since. We have customers all around the world, including equipment manufacturers, system integrators, and electrical utilities. We have a wide array of products that we sell, including source code libraries for DMP3, 61850, 6870, 101, 102, 103, and 104, TASI2 and ICCP, and Modbus. You may have also heard about our SCADA Data Gateway, which is our gateway application for protocol data mapping and concentrating. And we also sell a collection of testing tools like the 61850 Test Suite Pro, Distributive Test Manager, Test Harness, and Iron.
Hi everyone, this is Sharon from Clarity. So I would like to introduce you to Clarity. Clarity is the leader in operational technology security and improves the availability, safety, and reliability of OT environments for enterprises and critical infrastructure operators. So far, Clarity has raised more than $100 million and we have around 200 employees around the world. Our investors include leading companies such as Tomsec, Team8, but also leading OT vendors such as Rockwell, Schneider, and Siemens. In terms of integrators and integrations and partners, we have many partners and platforms we work with, including Checkpoint, CrowdStrike, and more. Next, please. So what you see on the screen is my team. I'm leading a group of researchers that explore the ICS threat landscape and looking for vulnerabilities in both hardware and software solutions. Our daily job mostly consists of building and breaking ICS related equipment, and we do security assessment research to find bugs and vulnerabilities. Once we find those, we safely disclose the bugs and vulnerabilities to the vendors, and we're actually working hand in hand with them in order to remediate all the found issues. As you can see on the right screen of the screen, we have disclosed more than 55 vulnerabilities, which are identified by CV numbers just in 2020. We have much more. And apart from that, my team has participated in multiple hacking competitions, including CTFs in DEF CON, S4 conference, and Pwn to Own. Thank you.
So I'm going to talk a little bit about our agenda today. The first thing we're going to do is we're going to introduce Triangle Microworks' Distributed Test Manager, or DTM. We're going to talk about different malware, including specifically focusing on the Indestroyer's payloads. Then we'll move into the DTM demo for the substation and malware simulation that we're doing. From there, we'll move on to the ICS targeting malware. We'll go much more in detail about what the Indestroyer does, its history, and an analysis of it. And then we'll finish it up with a CTD demo about detecting malicious activity. We will be pausing for questions and answers in the middle that's sprinkled through here, and of course at the end. So let's talk about very basic substation networks. What we can do is we have Distributed Test Manager, which is our substation network simulation tool, and we'll be presenting that today. It allows for protocol devices, including 6870, 101, and 104, ICCP or TASI2, DNP3, Modbus, and IEC 61850 devices to be simulated. DTM will be used to simulate the substation that Clarity will be monitoring. DTM will not only be simulating the 61850 protocol communications, but also the substation behavior. We will be adding a script to this that will be simulating the attack similar to the Indestroyer's malware attack. So this is kind of a normal network layout. In our simulated network, we'll have our substation IEDs that will be monitoring information and sending them up via 61850 reporting to the substation HMI. There will also be Goose published among the IEDs themselves. We've also added a semi-periodic control from the substation HMI down to a select few of the IEDs. While it'll be more frequent than you'd expect in a normal system, it will add a little more detail to the simulation for a more well-rounded system for CTD to monitor. So let's talk about malware and Indestroyer for a little bit. The type of systems that we just described can be attacked by malware. The Indestroyer is a type of malware specifically designed to attack system substations. So our demo today will be focusing on the Indestroyer, but the same idea that we presented here for Indestroyer could be applied to many other forms of attacks. So let's look exactly at what Indestroyer does when it comes to the protocols themselves. What Indestroyer does is it gets into your network and performs several tasks. The first thing it's going to do is it's going to try to figure out who it can communicate with. It can either do this by two ways. The first is if there's a file that is provided with this, if someone has some insider information, that file can be filled out with the IP addresses of all the devices it can communicate with. But more likely what it's going to do is it's going to analyze the machine that it's infected. It's going to look at each of the network adapters on that machine, find that machine's IP address and subnet mask, at which point it will ping all the IP addresses that it possibly can using those 2 bits of information and wait for responses. Once it gets responses, it will then generate connections to all the IPs that got responses from on port 102, which is 61850's primary port. After connecting to the IEDs, it'll perform a discovery on all the responding devices, essentially gathering up all the data attributes and models stored within all those IEDs. The malware will then search through those models looking for controllable or writable points, and it will then try to perform any sort of switch or breaker position commands, essentially toggling them back and forth. The main intent here is to cause as much havoc as possible. After that, it will record a log of everything that's accomplished, and it will step out of the protocol section of its malware. So let's take a look at what that looks like. So we've got our normal network layout again. Then the Indestroyer can enter the network via many routes. For example, it could infect the substation HMI. Then it'll start looking for IEDs to attack via ping and 61850 discovery. Once the IEDs are discovered, then it'll issue commands to control certain points, such as breaker or switch positions. So now we're going to pause here and look at DTM a little bit. I'll give you a quick overview of DTM and show you exactly how we simulated that in DTM. So this is our distributed test manager, or DTM tool. Effectively, what we have to match it up with the diagram we were looking at before is we have a folder for the IEDs, we have a folder for the HMI, and we also have a folder labeled attack. So inside the IEDs, you'll see all of the 61850 devices that we are simulating. You'll also see a single line diagram here in the middle, and the values are being updated live. So we have a few CTs, or current transformers, here, and you'll see that this information is live. So if I opened up this breaker here, this line no longer has connectivity through and through, so the current will drop to 0. We also have a few things I won't be touching on today, like some of our protection schemes going on in the background. And we also, as you can see here in the output, have a semi-periodic command causing this breaker that is highlighted here to open and close. On the HMI level, we have a singular device connecting up to a few of the devices in our system. We also have this folder here called attack, and this is where the malware attack is going to be simulated. This simulation is done via these two scripts here. The first will generate the attack, which will be basically the master JavaScript, and then I also have a separate JavaScript called ping that will perform all the ping functionality in the system. And the reason these are broke up between two different scripts is because originally I had this going cross computers and I needed to run the script on one computer and this one on a different one. So let me go ahead and execute this. And so what we'll see down here in the output is we're sweeping all of the IP addresses that the malware thinks it can connect with. For the sake of time, I've limited it to the first 25. But you'll see the red is no ping response, whereas we are getting some connection responses on the black return text. At this point, what it's going to do is it's going to start building up our 61850 clients and perform discovery on each of those devices. And the reason we're doing this is that way the malware will know exactly which controllable and writable points it can interact with. You'll see that most of these devices are not connecting. As you can see, the connection indicator here is orange. But on the ones where the ping did respond, we'll see a green connection, meaning that a 61850 communication has been established. So we just got to generate a few more devices here. And of course, in the output, you're also seeing when there is a successful connection to our servers. So now that all the devices have been created, we're now going to sweep through a large array of controllable points. A few of them you'll see kind of out here in the single line diagram, like these switch states here, and the breaker position as well. But because of the randomness of how these commands are sent, you may see an output like this. And essentially that was the malware trying to set, say, a breaker position to close when it is already closed or it's already enacting. So you'll see here that this line that could go to a neighborhood or a whole different area of the power grid is now off. There's no current going through, all the switches are open, and this is obviously not the nominal behavior. So that's how we go about simulating a substation in DTM, including all of the IDs, and how we can set up a simulation of a malware attack. I've got one more slide that I'm going to be going back to, and then I think we'll be stopping for Q&A. So today we focused on 61850 attacks. The Indestroyer is actually much more intelligent. It has payloads for a very similar type of payloads for the IEC 6870, 101, and 104. And then it has different types of attacks for systems that contain OPC DA and the Siemens C-Protect devices. So I think at this point, I'm going to hand it back over to Beth, see if any questions have been piling up or we have things to answer, and then we'll move on.
We do have a question that came in. Is it possible to import SSD or SCL 61850 files to configure DTM?
Yeah, absolutely. So our DTM and Test Suite Pro tools can use a wide variety of SCL files, including SSD, CID, ICD, IED, SCD. I'm sure I missed a bunch. But essentially, we will try to take the widest, well, we cast the widest net possible in order to simulate as much of the 6150 devices as our customers can have.
Okay. Okay, that's it for the questions now. So I'll go ahead and switch it over to Sharon to get started with his presentation. All right, Sharon, you are the presenter.
Okay, so hi everyone, Sharon from Clarity. So up until now, we've seen the simulation of such an attack, like in Destroyer, but it can be any other malware. But before we're diving into the technical details of such an attack, I would like to go over a bit on how OT networks are constructed and why and how attacks occur inside these OT networks. So first of all, I would like to go over on a couple of news reports from the last couple of years. So in recent years, we've seen many cybersecurity incidents in different industrial sectors, including nuclear plants, including electrical grids, water pipelines, a lot of industrial sectors. So first was Stuxnet, which delayed the Iranian nuclear project in a few months by messing around with the Siemens equipment controlling the centrifuges. We also witnessed Honda shutting down some of its factories because of a targeted ransomware attack, which was a deadly malware named Snake. There are many other hushed stories like this that companies are trying to hide from the public for obvious reasons. They don't want to be embarrassed. But the message here is clear. Cyber attacks on OT network is happening and it needs to be taken care of. This is the holy grail of nation-state cyber warfare, and hackers are targeting these networks on a daily basis. So now I would like to discuss how such an attack is being done, why, and finally show a demo of how we, Clarity, can detect such an attack. So first of all, we would need to ask ourselves why hackers are targeting OT networks. And I've came up to the conclusion of two main categories of reasons. The first one are political reasons, the cyber warfare. Nations are fighting each other, and another dimension of a warfare is the cyber world, the internet. So in 2011, we had Stuxnet, the world's first publicly known digital weapon. The malware attacked Siemens PLCs and caused a massive disruption in a nuclear facility by silently playing with centrifuge speeds. So it changed how the centrifuge speed is spinning, and it caused massive disruption to the content, to the Uranian content itself. In 2017, we had Triton. Triton was industrial safety systems in the Middle East that was targeted by sophisticated malware named Triton. The malware attacked mainly Schneider's Triconix controllers, and again, it caused huge damage to the factory. So these are all cyber warfare reasons, political reasons, but they're also activist reasons. We sometimes see activist groups trying to harm and infiltrate OT networks in order to demand a political thing or in order to make a statement. Another set of reasons would be financial reasons. So sometimes we do see hackers trying to hack companies and factories in order to extort money out of it. For example, in 2020, we had Honda attacked by the Snake ransomware. It was deliberately attacked Honda's network for extortion reasons. So Now that we understand why attackers are hacking OT networks, we need to discuss what is the end game. So when we're talking about attacking OT networks, the end game will always be destruction. So chaos, destruction, anything that can cause a real damage. It can be done by multiple ways. First of all, shutting down equipment can cause manufacturing delays and disruptions. So for example, this talk today is focused on Indestroyer, which turned on and off electrical switches, relays in an endless loop, and by that it caused massive disruption. It caused almost the entire Kiev city in Ukraine to shut off. So it destroys the equipment and causes massive electricity disruption. Another attacking vector would be to modify the parameters. For example, Stuxnet changed and played with the speed, direction, and the amount of the centrifuges. And another dimension of attack would be to wipe or to encrypt the data on the OT computers. So we have a couple of examples like that. For example, the Snake ransomware, which attacked Honda a few months ago, it caused massive disruption just by being a ransomware, just by encrypting the files on the OT network. And the result of each one of these attack vectors would be massive disruption. So this is the result of a successful attack. Almost the entire Kyiv city in Ukraine was blacked out completely in 2016 due to a deadly cyber weapon called Indestroyer. The electrical grid simply collapsed due to a targeted attack, which we're about to explain in the next few slides. So first of all, before we're diving into the technical details of the Indestroyer malware, we need to understand how OT network is built. So let's discuss how attackers are infiltrating the internal and sensitive OT networks. The diagram you see in front of you is the Purdue model, which describes a typical OT network layout and how it fits in a larger IT network. So let's start to cover it from top to bottom. At level 5, the outer layer is the internet layer, which the machines sitting in the internet layer, basically machines facing the internet and devices such as external firewalls, VPN servers, and more. Below that, level 4 is the corporate IT network. This is typically the IT network as we know it today, where the primary business functions occur. This is where people are managing the business-related activities, the manufacturing operations, and you usually know this by ERP. So this is the primary system that manages the entire operation. It establishes the basic plant production, schedule, material use, shipping, and inventory levels. Below that, we have level 3.5. So this is the demilitarized zone, DMZ. A recent addition over the last decade. This is actually a level that includes security systems such as firewalls and proxies used to separate or air gap the IT and the OT networks. So this layer is used to keep the OT network safer. In fact, this is where the IT and OT world converge, increasing the attack surface for the OT systems. Below that, we have level 3. This is the manufacturing operation systems. This is where managing production workflow to produce the desired products. And this includes batch management, manufacturing execution management systems. It also commonly known as MES systems. This is where maintenance and plant performance management systems are sitting, and data historians and related middlewares are sitting as well. Below that is the most important is one of the most important levels in OT network. So this is the process network. This is where supervising, monitoring, and controlling the physical processes involving real-time controls and software. And in this layer, we have DCS systems, HMIs, human machine interface, SCADA systems, and other monitoring and controlling machines. Below that, we have the level 1, the control network, and this is where the hackers would really like to get. This layer contains the process brains, PLCs, and RTUs. The main logic of how to manipulate and control the field devices is found within those devices. Attackers that will be able to access and interact with these devices will be able to influence the control processes. So for example, shutting down the electrical grid will be conducted by communicating with one of the devices in this layer. Below that, we have level 0, the field devices, the physical processes. So it defines the actual physical processes, or in other words, sensing and manipulating the physical processes. This includes sensors, actuators, and other related instruments that are acting in our physical world. That's why we call them field devices. So just to conclude here, attackers would like to get to level 1. To level 1 because they would like to communicate with the brain of the processes. They would like to affect how the PLCs or RTUs are communicating with the field devices, and by that try to influence the process control. So now we would like to go over how hackers are penetrating OT networks. So usually hackers would like to get to level 1 in order to communicate with the PLCs. And to do that, they would need to go from the IT network to level 3.5, which is the DMZ between the IT and the OT network. And from there, they would need to go to the OT network. So first of all, they would need to infiltrate the IT network somehow. Then they would need to understand how to get into the OT network by exploiting or by lateral movement through the DMZ. So this is one possibility of how hackers are infiltrating the OT network. Another way of hackers to infiltrate the OT network would be through remote access solutions. So as we've seen in the Purdue model here, sometimes we have VPN or remote access solutions that would give operators and engineers a direct access into level 1. And that's because they need to control and maintain remote sites. So they themselves need somehow to get into the PLC networks without being on in the networks, especially in the COVID era where everybody are working from home. So another possibility for hackers to hack into the OT network would simply be to steal credentials of an engineer or technician or operator that are managing remote devices. Another way of hackers to infiltrate the OT network would be by misconfigurations. So sometimes there are machines with multiple legs, one interface in the OT network and one interface in the IT network. So sometimes if such misconfigurations occur, hackers can exploit this. And we also have something I call jumping laptops. So we have an engineer laptop moving around between networks. So if this engineer gets attacked by a malware, the malware can infiltrate the OT network once the laptop is brought into the OT network. And finally, we have a physical access. You need to remember that OT network is spread across very large area. So we have multiple sites sometimes, we have huge factory, sometimes we have multiple factories across countries or continents. So once hacker gets a physical access to one device, one PLC, from there it can do lateral movement, it can pivoting inside the network and can reach other network devices inside the OT network. So this is how hackers are getting into the OT network. But we would like to discuss Indestroyer. And Indestroyer is a malware, is the final goal, the objective of hackers once they're inside the network. But before that, there are a couple of stages of development. So we call this the ICS cyber kill chain. So this is how hackers start with the idea of they want to hack somewhere, how they develop their tools, how they deploy the tools, and finally get the actions done, get their objectives. It all starts with the reconnaissance phase. In the reconnaissance phase, hackers will collect data on the target. It can be by harvesting email addresses, conference information. It can be by understanding what kind of operating systems or other systems are being used in the IT or OT network of the company they want to hack. And By collecting all this information, they can move on to the second phase, which is the weaponization phase. In this weaponization phase, the hackers will start to build and develop their own tools based on the information they collected. So if they know a specific Linux version is being used, they will develop a specific malware targeting this specific Linux version. So this is the weaponization phase. In the weaponization phase, hackers will also start to develop exploits to exploit the specific equipment they were able to understand being used in the network in the reconnaissance phase. Next, they will deliver it in the third stage. They will deliver it to the company they want to hack. And by deliver it, it can be by phishing, by email. They can build a special website, malicious website that once a victim goes onto it, it will attack the victim. It can be by exploiting remote VPN or firewall that we've seen in the last couple of months. It can be via any method that the hacker think it's suitable based on the information they collected. Next would be the exploitation phase. And the exploitation phase, the phishing email or this malicious website will attack the victim, and it will move on to the fifth stage of installation, where some kind of a stage 1 or something we call a backdoor will be installed on the device, on the machine, on the first entry point of the attackers to the network. Next, the backdoor will call home, just like ET. It will call home and ask for directions. What should I do? And usually it will call the command and control server. The command and control server is the server that will direct the backdoor what to do next. And usually these commands would be to install new malicious software or to exploit more devices in the network, or it can be to execute the final objective with step number 7, to execute the final payload. And in the industry case, the final payload was to attack IEDs. IEDs are the machines that monitor and regulate the power and electrical grids, which we'll cover in a bit. So now, after we understood how hackers are attacking OT networks, why, and what is the ICS cyber kill chain, we can move on to understand how the industry malware that we're trying to simulate and detect with this demo is working. So now we'll move on to the industry and we'll discuss a little bit about it. So first of all, history. Industry is a special cyber weapon with the objective of disrupting electrical system. It was used in the cyber attack on Ukraine's power grid on December 17th, 2016, and it caused mass disruption. The malware attacked and was able to cut off 5th of Kiev, the Ukraine capital Kiev, 5th of Kiev power. So most of the people in Kiev in 2016 December had no electricity because of a cyber attack. This is huge. The attack itself, the incident, was the second cyber attack in Ukraine's power grid in 2 years. And the first attack occurred on December 23rd, 2015. So it wasn't the first time that this network was attacked, and the hackers knew what their objective was. They knew what to do. They knew how to hack into the network and how to deploy their sophisticated malware. And what's important to say here that the industry is the first ever known malware specifically designed to attack electrical grids. And the target of this malware was these devices. These are IEDs. So in the electric power industry, an intelligent electronic device is an integrated microprocessor-based controller of power system equipment, such as circuit breakers, transformers, and capacitor banks. In other words, this is a device with a simple goal of monitoring and do power regulations. And once this device was attacked by the industry, there was no power regulation, there was no monitoring, and basically what the industry did is to open and close circuit breakers all the time in order to cause massive disruption in the electrical grid. And it did succeed, and for a few hours in 2016, there was no power for Kiev's population. So it really makes sense that the industrial malware tried to attack specifically these IEDs in order to influence the process control and to damage the electrical grid. Now, let's move on to understand how the malware operated within the network. And by that, I want to start with a simple diagram of how the malware was architected. So first of all, we have the command and control server. This is where all the commands to the malware got from. So the main, let's call it the first component of the malware is actually the main backdoor. And the main backdoor was used to control all the other components of the malware. It connects to the remote command and control server in order to receive commands from the attackers, from the CNC. It did a couple of things. First of all, it had a launcher, and the launcher component is a separate executable responsible for launching the payload components and the data wiper component. The launcher component contained a specific activation time and date to start the attack, and we've seen a couple of payloads for the launcher. So we've seen 101 payload. So this is a protocol stack 101 with the only goal of attacking IEDs and actually open and close circuit breakers. So the attackers implemented multiple payloads, multiple protocol stacks related to ICS, related to electrical grids protocols in order to open and close circuit breakers. So this is the launcher. The launcher activated the payloads. The main backdoor also installed additional backdoor for a backup, and it used additional tools that we'll discuss in a bit. Now let's dive into the backdoors themselves. So once the attackers obtained administrator privileges, they were able to upgrade the installed backdoor to a more privileged version than is executed. So it was actually a Windows service program that did all the magic, and with just replacing the image path in the registry, they were able to elevate permissions and execute themselves as a service on Windows. The main commands were to execute another processes or to copy and upload files to the CNC. As I said before, this backdoor had additional backdoor. It was actually a Trojanized version of the Windows Notepad application. So anytime the operator opened the normal Windows Notepad, it actually activated the secondary and backup backdoor. The launcher is a very simple binary. So the launcher, you can see here the command line for the launcher. All it needed was a working directory, the payload to load, and the configuration file. So each payload had a different configuration file. And you can see here, we had the industry had a couple of payloads. So it had the 101 payload, it had 104 payload, 61850. This is what DTM simulated in the demo today, and it had OPCDA payload as well. So the attackers implemented a complete protocol stack of all of these protocols in order to cause mass disruption via communicating illegitimate protocols. And the final component of the destroyer was the additional tools. So it's a couple of additional components. We categorized them as additional tools. So it had a port scanner. As you can see here, this is how we ran the port scanner. So you can see it's very basic port scanner. It had a data wiper, which just deleted files on all the computers the industry ran on to delete any traces, to delete any forensic evidences. And it had a Siemens CProtect denial of service exploit, which is marked as a CV 2015-5347. This exploit actually communicated with a Siemens ID, as you can see here. This is the CProtect IED. Sent a malicious payload to the exploit, and the machine just crashed. So this is a very known exploit, and the machine just completely crashed and got into a denial of service condition. So the entire goal of the industry was to destroy the machinery, the IEDs inside the network, again, in order to cause mass disruption of electricity. Now, as I said, all of the protocols being used are legitimate protocols. So the question is, how can we detect? How can we detect a legitimate traffic when it is being abused? And the answer is an holistic approach which combines multiple detection engines of different fields. So Clarity's flagship platform is called CTD, Continuous Threat Detection. And CTD consists of a couple of detection engines which together provide full monitoring coverage of IT security and integrity events. So we have a couple of engines which I would like to cover. And then I will show you a demo of how it works, everything together. So our engines include anomaly detection, which identifies changes in the communication patterns, which we call baseline. So we're trying to see if something deviates from the normal baseline of the network. We have some security behaviors, which identifies adversary techniques used in attacks against IT or OT networks. We have known threats, which includes IOCs, Snort, Yara, and other engines. We have operational behavior engines, which identifies OT operations such as a firmware upgrade, download or upload of configuration for devices and controllers. We have custom rules, which identifies user-defined events, and we even have cloud connectivity to get the wisdom of the crowd. So before moving on to the demo, I would like to ask if you have any questions.
Yep, we did have a couple of questions that came in. Let me start with the first one. Your assumption is that the HMI has been infected. Does that mean that the attack will come from the same IP as the HMI has? Most of our substations only accept connections from fixed and configured IP.
Yeah, sorry for interrupting, but yes, the answer is yes. The HMI was compromised, and all of the malicious communication that was received was from the HMI. So it's a kind of hard and difficult to understand whether this kind of traffic goes out from the HMI is malicious or not. And using the holistic solution I offered, it kind of solved this problem.
Okay, next question. It was mentioned that hackers want to access level 1. Do you have any indication of target changes due to the digitalization of the field devices? It will be much easier to attack these devices and attack them through the level 1 devices.
So I'm not sure if the question points to field devices being digitalized and adding some features like cloud connectivity or not. So I'll try to give some abstract answer. In the recent years, we've seen some sensors and actuators and other field devices being added some cloud connectivity, and Clarity are researching this field as well. So we're trying to monitor this this connectivity as well.
Okay. For cloud solution, VPN is most likely not part of an OT network. Where would the vulnerabilities be?
So usually in OT networks, we have remote access solutions. So sometimes they're being referred as a VPN, and sometimes they're being referred as a remote access solutions. But we do see OT networks with remote access solutions. And the vulnerabilities would be, so actually Clarity had a nice research on this topic a few months ago, so you can see it in our blog, but usually it will be in a couple of ways. One, it can be in the VPN client or the remote access solution client. So we're able to attack the clients themselves and then steal their credentials and log in on behalf of them. But it can also be the vulnerability can also be in the edge server, which receives the external connections And we were able to prove, again, that some servers, some remote access solutions are exploitable, and we were able to remotely from the internet exploit this server and infiltrate into the network.
Okay. Okay, we do have a couple of other questions, but I'm going to hold off on them for now because I want to make sure we have about 15 minutes left of the scheduled demo, but we will stay on to answer these questions. And I do want to encourage people to continue to submit the questions while Sharon continues on. You know, just a reminder, we do have a couple of folks behind the scenes. We have, you know, you're hearing from several industry experts, and we have several industry experts ready to answer you real time. So keep the questions coming, and we will get to them towards the end of the presentation. So Sharon, if you want to continue on.
Yeah, thank you. So I'll just conclude a bit. So up until now, we covered quite a bit of content. We discussed the history and the technical details of the industry malware. And we also discussed some theoretical ways to detect legitimate protocols when they're being abused to cause disruption. Now I would like to continue to our demo. And usually, CTD, our product, is fed with live network traffic from a span port, from the switch. But in this case, for the demo purposes and due to the COVID situation, we decided to separate the demo to DTM and CTD separately. So previously, you've seen DTM demo, and now I'm going to show you CTD demo separately. So as you've seen with Matt's demo, DTM is able to mimic industrial behavior by simulating its network traffic and how the malware utilizes Goose, MMS, and other ICS-related protocols. While running the simulation, Matt has recorded the network traffic and captured it and stored it into a pickup file. So he sent them over to me, sent the pickup, the network captures files to me, and I upload them to CTD as if it was a real live network. So now what you're about to see is our CTD system after it was after all the traffic was digested and analyzed by the traffic received from Matt's simulation. So let's get started. So this is CTD. This is the main dashboard of CTD. So what you can see here is an aggregation of all the network events, all the stuff that's going on in the network. So you can see here how many assets has been discovered. Currently, I'm filtered on the last year, but you can filter how many new assets were discovered today or yesterday. You can see alert status, so how many open events you have in the network. And we can see here that we have one story, which is critical, which is classified as critical. And we're going to discuss in a bit why we have one story while we have 29 alerts. We also have a couple of insights. So insights is our way of telling our customers what's important, what should be prioritized, and what important and special events happened in the network. So next, I would like to go to the asset page. And in the asset page, I can see all the different assets in the network. So everything that Matt simulated, we can see here as an asset. So we can see here many assets in the network. And we can see the vendor, in this case, Siemens. And we can see lots of devices. We can also take a look at all of these devices as a layered topology view. So it's very easy to understand what's going on in the network once we have the topology view. And we can see, indeed, just like I discussed previously, we're categorized all the assets based on their location in the Purdue module. So all of these are probably IEDs, and this is probably an HMI device. So we can see we have this HMI, as Matt showed you before, communicating with all these devices, probably monitor regulating, or in this case, all these IEDs were attacked by this HMI. So if we're diving into the HMI, we can go to see more details. So first of all, our system automatically detected that this is an HMI. and specifically detected what kind of operating system it's running on this asset. And it's really good for asset management. We also have some graphs and statistics, which I don't want to go over right now. I do want to go over to device information. And here we can see what kind of protocols this device communicated with. We can see where it sits in the Purdue level, and we can see even what kind of installed software it has. We also, through CTD, managing the risks and vulnerabilities of the devices in the network. So for example, if we're detecting an old operating system and we know that there are a couple of vulnerabilities for it, we will aggregate all the information into this screen. And this way, we're telling our customers what to prioritize first. So anything that has higher risk should be prioritized and patched first. We also have some insights like what kind of operations this asset was involved with, what are the CVEs or vulnerabilities that this asset has, and if it's running a web client, for example, a browser, we can also present what kind of files were downloaded. We also have threat detection, and this screen actually tells our customers what happened in terms of security events to this asset. So we can see here we have lots of events, lots of alerts, 29, but they're all aggregated into one story. So we decided that showing lots of alerts is not beneficial for our customers because it's not telling a story. And so we were able to understand the scope of all the alerts going on in the network and combine them into one story, one meaningful story. So if we'll go to the story, we can really, as it sounds, really tell a story through all the alerts. So here again, we're presented with the HMI and all the IDs. And here we can really understand by going through the alerts what happened. We're telling a story. So for example, here we can see that a suspicious file transfer was found, and we can see here that a file was downloaded. So this guy downloaded a file from this guy. So this is probably the CNC, and this is the HMI with the IndustriWire, because we're seeing here that our Yara engine determined that a file that is part of IndustriWire was downloaded. So we can see here a couple of files that are marked as IndustriWire were downloaded through this guy. So now we're starting to understand that this HMI actually downloaded a malicious file from the CNC, and next it started to run the payloads against all of these devices. And we can see this because suddenly some new commands were starting to run in the network, and this HMI started to attack all of these devices. And we can see it here by all the IPs. We can even see more details if we'll go to event details, but instead of doing that, I would like to go to our process control. So not only that we're tracking all the baselines, so here we can see all the baseline summary, what kind of protocols were used, what kind of ports, what kind of requests, we're also seeing what kind of process values or tags were transferred in the network. So for example, if the malware, the IndustriWire malware, wanted to send a request to open or close a circuit breaker, it would actually send a tag request or a write request, which we're capturing and monitoring. So here we can see all the different tag write requests. And by that, we can even filter by protocol. And by that, we can do a very good forensics of what really happened in the network. What kind of tags were written, what kind of protocol requests were sent in the network, and we can start to construct the complete image, the complete picture of the entire attack. So this was our demo of CTD. Of course, we have lots of more engines. We have lots of more features to show, but for this demo, we just wanted to focus on the relevant features for Indestroyer. So I think now it goes to Matt.
Yes, thank you. I was answering a few questions. Sorry for the delay. So that, like you said, that concludes our CTD demo. We're going to kind of move into some final thoughts here and talk about a little bit of what we've seen today. So the next thing we kind of want to talk about is you've seen the damage that malware can cause to your system, and you might be interested in ways to kind of minimize this risk. The easiest first step into cybersecurity is to add some sort of form of device authentication. We can use Garibaldi's key distribution center, or a protocol level secure authentication can be added to your system to do this. And they both work in a very similar manner. They work by verifying the identities of each of the devices on your network via private keys. This guarantees that you're not receiving controls or commands from rogue devices or malware on your system. Next.
And so we wanted to give a couple of tips, security tips, to secure your network and minimize the risk inside your network. So obviously monitoring and understanding the threats in your network is key. So monitoring all the assets, understanding what kind of assets you have in your OT network, because we all know that OT networks contain hundreds, if not thousands of network devices. Also creating a testing incident response plans would be good for a dark day. So you need a plan to understand what's going on in your network once a cyber event is happening. Also assessing potential risk in your network by identifying old versions of operating systems or old software versions or old devices would be always good to prioritize what's going on in terms of what should you patch first. And finally, some kind of a generic tip that is always good to have is using a multi-factor authentication, specifically for the remote access solution. We have seen before companies not using MFA for remote access solutions, and once the credentials of one user were stolen, the entire network was compromised.
So we've talked about DTM today and how it can simulate partial or entire systems. That includes not only the protocol devices and their communication, but also behaviors. This allows you to increase your confidence in your cybersecurity software by simulating attacks in a safe simulated environment. During these simulated attacks, this is when you can verify that your system is properly responding to the attacks and potentially eliminating any sort of risks or damages to your systems.
Yeah, and with the CTD, we showed you how it can help you monitoring your network, including doing asset management, doing segmentation in your network, doing threat detection. It can help you with understanding what kind of malwares and what kind of vulnerable devices you have. And by doing vulnerability management, you can prioritize what should you patch first, what should you take care of it first. So thank you, and I think if you have questions, now is the time.
Yes, we certainly did get a lot of good questions coming in while you were walking through that demo. So I'm going to start with that. First, let me just acknowledge that we have hit the hour mark. Like I mentioned earlier, we are going to stay on until the questions are answered. So hopefully you can continue to stay on. And with that, we'll just jump right into the question and answer section. So Sharon, I believe this first one is for you. Did all the IEDs have to be replaced following the Kyiv attack, or was the operator able to reset the equipment and reuse?
So I'm not sure exactly what happened in this case. Usually what they would do is they would reset all the configurations on all the devices, and they will start to clean up the network. Sometimes it includes formatting and restarting the devices. but sometimes it would mean to replace devices completely. So in case of a sophisticated backdoor that it's impossible to remove, sometimes they would replace the entire device.
Okay. And I'll just make a note to the other organizers that are on the call. I do have everyone off of mute if anyone wants to jump in with an answer to any question. Next question, how can we clean or stop the malware activated in the victim?
So it really depends the situation. It's hard for me to say anything too much broad and generic, but it really depends the situation. So in case of ransomware, sometimes just formatting the computer and uploading backups would be enough, but in other cases, some more countermeasures needs to be taken care of.
Okay. The next question, in case an IED is infected, which possibilities does an attacker have to attack the SCADA computers? Are you able to give examples?
So I'm not sure about the question. The IED was attacked, and then what?
In case an IED is infected, which possibilities does an attacker have to attack the SCADA computers?
So usually it will go the other way. It will go from the SCADA systems, like in this case the HMI, to the IED. But in this case, what you're referring to is the bottom up, which is not a likely cases with IED, but it is a possibilities. So in this case, it will be, first of all, very suspicious that the IED is starting to communicating and starting to send requests from the IED to the SCADA machine. And for instance, our CTD will detect it immediately because this is obviously a baseline deviation of the network.
Okay. Matt, I believe this next question is for you. IED and ICD files, can you give details about all the connected devices known?
So I think this might be one that I already responded to. Can you repeat that one more time?
Sure, and you did, yes. IED and ICD files, can you give details about all the connected devices known?
Yeah, I thought this was a really good question, so I'm glad you kind of brought that up. So some SCL files, like SCD files, do have some of that information stored inside of it. But the big fear is that the malware, especially the Indestroy, and I'm sure other forms out currently, don't really need that information. It has the ability to look at the device that it infected's network adapter, specifically its IP address and its subnet mask, and sweep the entire system that it may have range to attack to. So it can actually locate all of the devices out in your system without necessarily needing an SCD file or insider information.
Okay. And I do believe this next one is for you, Matt, as well. Which protocols are used to discover the devices?
So that question, I assume they were talking about 61850 discovery. And so what 61850 discovery is it's the ability for you to instance a 61850 client that may not know what its model is. And as soon as it talks to the server, it essentially says, hey, I need to know your model so I can reflect that on my side. It's a very powerful tool for when you are trying to connect up to servers and you don't necessarily have the files, which makes it perfect for malware, because people who create these malware or these viruses, the worms, whatnot, that infect systems, they don't have access to the configuration, the engineering files that were developed for these IEDs. And so it allows them to gather information that they wouldn't originally have access to.
Okay. Sharon, I'm going to switch back over to you. What kind of ability do you have to detect new attacks exploiting previously unknown vulnerabilities?
So once again, we have a couple of detection engines that they're all working together. We're trying to be as holistic as we can. So in case of a new exploit, it will generate, the usage of this exploit attempt will generate new type of traffic in the network. And since we're always looking for deviations in the protocol request, we will detect this attempt as a deviation. So first of all, when we're deploying our systems, we're baselining the network. We're trying to understand what is the normal state of the network, what are protocols are being used, what ports are being communicated. And if we'll detect an exploit attempt that was not part of the baseline, we will declare it as a deviation.
Okay. Next questions for you, Sharon. What kind of probes agents is needed for CTD to get this information?
So all is needed is a span port. So we're the basic usage of our solution is completely passive. We're just receiving traffic, network traffic from a span port. But we do have some other more advanced engines like Active Engine that can scan the network by itself. But the basic usage is simply giving a network traffic feed into a system. So that's it.
Okay. Is it possible to access a COM port by two different processes? He's got a follow-up comment here. The COM port access to send payloads is exclusive to the legitimate protocol software.
So specifically in Industry, what it did is it first killed all the processes that use the COM ports, and then it initiated the attack. So specifically regarding the question, it is possible by injecting packets into the process that was occupying the COM port. But in the Industry case, the solution was much simpler. It just killed all the processes that communicating through the COM ports.
Okay. Is the CTD solution deployed corporate-wide or at a site level? How is it licensed?
So about licensing, I'm not sure. You'll have to ask our sales department. But in case of deployment, we can deploy CTD on each site, and then we can control all the sites together. We can have another oversight solution called EMC, which controls all the CTD in all sites together. So we can control from one central location all these instances in all the sites.
Okay. How will CDT monitor comms when they are encrypted?
So it really depends how we're seeing the traffic and where. So sometimes we're deploying our CTD after or before the encryption occurs. So it really depends the situation. But all in all, if we don't have the keys for the encrypted protocol, we cannot decrypt it.
Okay. What is the method you are using to detect attacks, and how are you preventing them? So what is the method you're using to detect attacks within CTD or CDT, and how are you preventing them?
So yeah, as I said, we're not preventing, we're a passive solution. We're just monitoring. But how we detect attacks is, again, we're using the holistic approach of a couple of detection engines where we have a behavior, the detection engine, we have our baselining and trying to understand deviations in the network. We have our Yara and Snort engines. So we have a couple of different engines that are all working together in order to detect attacks in an OT network.
Can you install CDT in any substation?
Yes.
Okay. And this might touch on a little bit of what you just answered. How do you implement such a system? Is it a passive IDS with simple monitoring ports?
So our solution in its basis is an IDS, intrusion detection system, but we have multiple engines working together. So it's not just a single IDS like Snort. We have sophisticated algorithms that are trying to understand the deviations in the network. So we're not trying to understand just one thing. We're trying to understand the whole picture.
Okay. What are the other protocols supported other than 6870, 101, 104 OPC, and 61850 by CDT?
Wow, we support dozens, if not hundreds of protocols. You'll have to refer to our website for that.
Mm-hmm. Since you show us some protocols that are in use in OT, how deep do you inspect 61850?
So we have a very thorough dissectors that are able to understand all the protocols in a very high level of detail. So our DPI engine is very, very good. As I've showed, we're really understanding not just the request, but also we're extracting all the values, and we're able to show to your customers exactly what kind of tag was written or read from and how many times. So we have a very sophisticated DPI capabilities.
Okay. Can the device IED address be recorded or encrypted instead?
So I'm not sure what it means be recorded.
Okay, that person is still on if you want to send a clarification comment. I'll skip over to the next question. We can come back to that. Matt, I believe this one would be for you. Is it possible to simulate the analog value continuously by varying measurements in an incremental way with DTM?
Yeah, that was a good question. So in DTM, there are several different ways that you can edit your values, whether it be a Boolean or analog value. We've got scripting, auto data changes, we've got CSV file playback. But if we're talking to the level of like sampled values, which is going to be in the milliseconds or 10 milliseconds, we do have a little bit of a time constraint at that level because we do run on the Windows operating system. But up at the like hundreds of milliseconds level, we keep up with pretty well. So it really depends on your definition of continuously. So I would say tentatively yes. But if you're talking about, sampled values doing, a full, sinusoidal wave or a power curve or something like that in the ones of milliseconds level, that's not something we generally can do right off the bat.
Okay, another one for you, Matt. If you don't need to see the SCL file information, how are functional problems detected in 62850?
Yeah, I wanted to be a little clear with this question because I wanted to make sure there wasn't much confusion. So when we are simulating the devices in DTM, Distributed Test Manager, we do use all forms of SCL files from all the way up from SCD files down to IID, ICDs, CIDs, anything along those lines. So that's how DTM knows exactly what type of device to simulate and how it's configured. When you don't, when I was talking about you don't need the SCL files, I was talking about specifically for the attack done by InDestroyer. While if they had that information, they might be able to have a more efficient attack. They don't necessarily need the SCL files because of its ability to scope out the network adapter and figure out any of the devices on the system that it can connect to and attack with. And at that point, once it's able to perform discovery, get the model of the device it's attacking, then it knows what it can attack. Specifically for this demonstration, it was switches and breakers, because once you open these breakers and switches, there's no more power flowing on those lines, which means, as shown in some of the pictures, cities are losing power, lights are going off, the really damaging stuff that can happen to the world. I hope that accurately answers that question. But I wanted to make sure I answered it from both sides to prevent any confusion.
Great, I'm going to switch back over to you, Sharon. Do you have any vulnerability database implemented in your solution, or do you do a vulnerability scan?
We're not active, we're passive, and we do have a vulnerability database with all CVEs.
Okay. Another question for you. If an attack is already detected, then what should be the first line of action to prevent further damage to the network system?
So first of all, I would recommend to cut off the power for all the network devices, so the attackers could not communicate to their CNC. And then a thorough investigation must occur. So the organization must understand how the attacker is infiltrated inside in order to close this vulnerability and this hole. And they need to understand how they spread and pivoted inside the network and what kind of devices were infected, and then start mitigating all the holes being found and format the computers, restore from backups, etc.
Okay. This question has kind of come up in a couple of different ways, so I'm going to ask it of you, Sharon. One, several folks have asked if they're able to get a evaluation license to try it out, and is it a subscription-based license product? And I know you mentioned that might be more of a sales question, but if there's anything you can shed some light on there.
Honestly, I'm not sure. They'll have to email the sales department. So I think it's sales@clarity.com, but you can see it in our website. You can request it. You can request a demo through our website.
And I will be sending out follow-up information that will have a recording of the webinar. We'll have contact information. For DTM, you can download an evaluation license directly from our website, trianglemicroworks.com. And try it out, but I will include the Clarity information in there as well. I've just seen that question come up a couple of different ways, a couple of different times, so I did want to make sure I got to that in general.
Mm-hmm.
Okay, another question for you, Sharon. How can the software analyze the traffic in case of a VPN tunnel from upstream all the way to the relay level where the traffic is wrapped with TLS?
So again, if it's wrapped with TLS and we don't have the keys, we cannot decrypt it. But it really depends where our solution is deployed. If it's deployed in the, let's say, level 1, the Purdue model, then we're seeing the traffic after it was decrypted, which means after the tunnel. So it really depends where CTD is deployed.
Okay. Is a separate computer required to run CTD in substations? Is it possible to access data of CDT in control center from all the substations?
So in order to run CTD, you just need a box. It can be virtualized or not. So you can access this box from anywhere.
Okay. In an OT environment, how many numbers of ports/devices can be monitored?
We have networks with tens of thousands of devices. So I'm not sure what's the limitation, but it's very high.
Is CDT able to monitor firmware upgrades to PLC, and how is it achieved?
Yes, we're able to do that because we have a very thorough deep inspection protocol mechanism. So we're able to understand most protocols in OT environments, if not all of them, and we're able to understand all types of requests. So in case of a firmware upgrade or logic upload or download, we will be able to understand it and notify our customers.
Okay, great. Matt, I do have a question for you. Is it possible to build test case and execute for testing functionalities of IEDs by DTM?
Yeah, absolutely. So that's one of the things that I didn't really go over too much today when I was doing my DTM demo. I showed off one kind of simple use case for DTM, but it actually is designed to sweep several different use cases. And one of the things that we didn't talk about was our test manager. And what the test manager allows you to do is set up multiple tests that you can run, say, as regression or you can run each time your system updates in any way, allowing you to automate these tests, run these tests, go get a cup of coffee or run them overnight or something along those lines, and come back. And you'll actually have a full printout of everything that was run while you were gone. And it also allows you to export these test results, giving you a paper trail of how things are going as your project is moving along. But yes, absolutely. And that is totally customizable, cross protocol. Anything that DTM can do, you can pretty much fit into the test manager one way or another.
Great. Okay, Sharon, back over to you. And I think this might be the last question. I think we're getting to the end of them. Is it possible to SDN switches minimize cyber attacks by strictly controlling all the flows?
Can you repeat, please?
Sure. Is it possible to SDNs switches minimize cyber attacks by strictly controlling all the flows?
So generally, yes, any restriction will help. It's just like firewalls.
Okay. Oh, did you just have one more pop in? Do analysis reports of the attack and previous history of the attack, are those generated?
So we are able to generate a report in our system with all the open alerts and all the stories and all the aggregated data. So yes.
Okay, and I think you've already touched on this answer before, but it did just come in, so I want to make sure we cover it. Is it possible to access data of CDT and control centers from all the substations?
Mm-hmm. Yep.
Okay. What format do you use for your syslog messages? I'm sure I'm not saying that right, but syslog messages?
Syslog. What kind of format? The most common one, I don't remember by heart, but the most common one for the syslog.
CEF, he's asking?
I think so. Yeah.
Okay. Do we have any backup systems for CDT like main and standby?
Not sure about this one.
Okay.
I will have to check.
And we can follow up with the any unanswered questions in the email. We do usually attach that with the follow-up that will get sent out. So if anyone had a question that did not get answered either online or here, we will send that in the follow-up email.
Mm-hmm.
But that does bring us to the end of the questions. I mean, we had a lot of good questions come in. I appreciate everyone that has stayed on. We had a very large crowd stay on for those questions, so that's great to see. Again, just want to remind everyone, we will be sending out a follow-up email with a link to the recorded version of this webinar. It will also have information on DTM and on Clarity and where you can download evals and get more information on certain things like the licensing and subscription that was also asked here. So again, thank you everyone for your time today and staying on even longer. And continue to be on the lookout for our next webinar that we will be hosting in January. Okay, thanks everyone.